Hello and welcome to this 3DO webinar preview. This is a small sample of the original presentation, but if you'd like to view the full webinar, please click the link in the description below.
Good morning, everyone. Thank you for joining us today for this webinar. We're going to talk today about investment casting versus metal 3D printing and what are some of the key differences and where metal 3D printing might be able to help with some cast parts for you. So before we dive into the meat of it, I should first give a little bit of an introduction. So I'll first say about 3DO. So we're an award-winning design, engineering, and manufacturing service provider specializing in small, complex metal 3D printed parts. We do things, generally speaking, from the size of a gumball to a golf ball to a softball in size, competitively against a lot of other processes where additive is required for the application. We offer customers true end-to-end solutions. So unlike a lot of 3D printing manufacturers who are selling you a machine, and then it's up to you to come up with the value proposition and the ROI on it, we're actually going to work with you to make sure that it is a full turnkey from idea to finished part. And so that's a little bit unique, and we're excited to work with you to solve problems as opposed to just handing you a tool. So as mentioned, our services go from the design engineering side to the DFAM, design for additive. And then also we switch into full high volume production once we've worked out a part with you. And so that can be anywhere from a few hundred parts for a run all the way up to many thousands of parts. Last year we had a part that we were running 5,000 a month of, and that's an average week for us. So to crank parts like at that kind of a speed. So that's a little bit different than a lot of other additive manufacturing providers as well. How you partner with us, we can start either at the very earliest stage with the conceptual designs. We can come in with component functionality optimization. So you already have a design, and it's just a matter of making sure that it's as well suited for additive and for the application as possible. Or it might just be you're ready to go straight to scale. So we can talk at any of those stages. But obviously, the earlier that we talk, the more benefit you'll get out of working with us. Cool. And then just a quick blurb on me. So I have been designing for additive manufacturing since 2006, which was when I was at Virginia Tech working on my industrial design degree. And I actually managed the 3D printing services for the architecture department while I was there. And that kicked off a career, and I've loved printing ever since. I have served in the market as an industrial designer and actually have a number of products out in the world. So can speak to consumer product design on that side as well. And I joined 3DO in 2021. And prior to this, I spent 3 years at Markforged. So I've got experience with Stratasys, Objet, 3D Systems machines, Formlabs machines, Markforged machines. So I've got a wide gamut of experience across all the different 3D printing technologies. And I'm currently really enjoying diving in on metals. But to speak now about what you're probably already used to for additive manufacturing applications there, aerospace, to which you may already be familiar. There's already a lot of use of additive for producing the forming tooling, especially for making layups and composites, and jigs and fixtures for assembly. There's also a lot of direct printing of composite structural elements. Yet again, having worked at Markforged, very familiar with the continuous fiber composites. There's also a lot of cabin interior components with the printing of ULTEM and other FAA-approved materials. We can actually do direct in-flight cabin parts for business aviation, and that's not a new application at this point. It's fairly well adopted. There's also the more traditional uses in the prototyping space of appearance models, form and fit test parts, wind tunnel scale models, and so on. And this speaks to the plastic parts that additive is already making an impact in aerospace on. But we're here to talk about metal parts, right? So thus far, as we've been expanding into aerospace, we at 3DO have discovered that there's a lot of parts that are great metal additive parts that aren't just the high profile ones that you're probably used to seeing in the LPBF, the laser powder bed fusion promotional materials. It's not all about the turbine components, the stators and the blades and blisks. Those are cool. But there's also a lot of parts that are traditionally cast or produced by other means that are now good application fits for 3D printing. So that's latches and retainers, buttons and triggers, brackets, levers, and cabin interior components seating hardware, there's some interesting things going on where there's a combination of casting and printing technologies as a hybrid. So basically doing lost investment from a printed starting point for your wax. So there's a number of different flavors of 3D printing that are impacting metal end-use parts in aerospace and that are getting qualified, and confidence is being built with FAA and the other regulatory bodies that these are ready for prime time. Also, something that's been more specifically focused on the rocket side of things, but fluid handling. There's also fluid handling in a lot of other places than just rocket engines, for which 3D printing is a great fit. Manifolds and hose junctions, nozzles, and valve bodies. There's a lot of opportunities there for 3D printing to achieve geometries that are otherwise a real pain to produce. So for a lot of those parts, a lot of them are traditionally made by investment casting. And so the general attributes of these parts that make them well suited for it is that they're typically small to medium sized, 10 to 300 millimeters on any one axis or smaller. There are larger parts, but generally speaking, investment cast parts are going to be, especially if they're in 70%, they're going to be in that small to medium size. And the required shape for the application is inappropriate or not ideal for machining, turning, forging, stamping, and so on. And so that's part of what makes them ideal for 3D printing. It might be that it either require a lot of material removal to machine it. It might not be generally cylindrical, making it not suitable for turning, or have features that extend outside the maximum working diameter of most machine tools. So you'd have to have a very large lathe. It may be that it's got sections that are too thick and too thin to be forged efficiently and effectively. And similarly for stamping, it might be a form that you cannot progressively stamp into the correct shape, even if you could make it out of sheet metal otherwise. So these things all might make sense to cast and then do secondary operations on these parts accordingly. Also, a part may have critical features, but not require features to be tight on tolerance all the way across the part. And so you may have key joints and pivot locations and so on that have to be held to a tight tolerance, but the general profile can be more loosely held, and that makes them suitable for casting and the variability in casting. And lastly, you might have parts for which the functional requirements allow designing an extra margin. I should say casting requires that you have to design an extra margin of safety to account for part and process variability, which we'll get into a little bit more a little later. So these are the things that make parts a good fit for casting. So it sounds great, let's go cast them. But what's the catch, right? There are some challenges, as many of you are already aware, with investment casting. And so before you spin up a new part into this process, you got to think about the lead time that's going to take to develop the tooling. And it's going to take a considerable amount of time, even once the tooling has been developed, to get it into the production schedule of a lot of investment casting foundries. They're currently considerably capacity constrained. And we've been observing in the customers that we're talking to, they're having a hard time keeping up with all of the different customers that they're trying to serve, given particularly the pandemic shutdowns and the challenges in sort of a post-COVID supply chain. So there's a long lead time to start, but there's also a long lead time to get something back into production. I'll do a run, and it might be a while before they can come back to you. Also, there's an intrinsic limitation in casting based on that process variability. And so you're going to have to work with a lower allowable engineering value for the material than you might otherwise if it were a raw material or produced via other means. And so those, because you have to derate the material, you have to then over-engineer the part. And so you end up with a more massive part in a lot of cases if you're doing casting than you might do if you were producing otherwise. There's also a quality control burden because of the variability in castings, particularly with porosity. You have to do, in many cases, especially for structurally critical parts, you have to do X-ray tomography or acoustic testing, and you're going to get NDT fallout as a result. With one customer that we've been talking to, they recently had an entire shipment that had to be reevaluated and tested a second time in order to qualify that it would be fit for use. And that was a substantial delay and cost for them, which is part of why they're considering switching from casting into 3D printing and have already moved some parts to us. Additionally, not only do you have to over-engineer the part, which makes for all kinds of accommodations in terms of form and fit, you also have to think about the weight cost. And in aerospace, of course, every pound that we're flying that we don't have to, we regret, right? So the fact that we're over engineering because we're accommodating casting is something we'd like to not have to do. Also, and I mentioned this briefly already, there's failures of the supply chain in this post-COVID geopolitical landscape. If you're sourcing your castings from anywhere in Asia right now, given the way that the US and China are currently having conversations regarding Taiwan, I wouldn't want to be dependent on my supply chain in that context. And also given that at any time ports may close again, particularly in China, given their propensity for lockdowns, that could put a substantial delay in place and make it hard for you to deliver parts to your end customer. And so it's just something to consider when you're sourcing from other countries, which countries are going to be reliable to source from in the current geopolitical landscape. And then lastly, there are form and feature limitations intrinsic to molding and casting processes. So when you're doing lost investment casting, you first have to essentially injection mold a wax, and then you're going to build up the ceramic shell, burn out the wax, and then cast the metal. So you have kind of two processes that you have to allow for and account for, that injection step, and then also the burnout and the casting step. And so you're accommodating the behavior and the constraints of getting a part out of a mold the first time in order to make it into a mold to run it a second time. So with printing, we don't have to worry about any of those things. So there are some constraints, but they're just different. And then lastly, and this is more of a longer term sort of strategic vision thing, but there are metallurgical constraints and thermal processing requirements that limit your design options when you're talking about casting. Certain metals, such as refractory alloys, require a much higher melting temperature and are therefore much more difficult to cast. And by using a powder metallurgy-based process, you can actually use a much lower sintering temperature than you would have for a full melt. And so that allows you to get access to materials with less challenge than you would otherwise. So all this is to say, okay, we've got these challenges. What's an aerospace engineer to do, right? So this is where with 3D, I would say additive manufacturing can come to the rescue. And we're going to talk about kind of three angles of this: the business angle, the materials angle, and then the applications angle.
Thank you for watching this webinar preview from 3DO. To view the full webinar, please click the link in the description below. If you'd like to learn more about 3DO, please visit our website at www.3deo.co.